Okay guys, let's talk about free body diagrams. And so there's a couple of free body diagrams you're going to need to know for the exam. Okay, so what is a free body diagram? Well, for the extent that we've discussed it, you essentially always have four forces that are acting on an object. Okay, now in reality, the direction of these forces is much more complicated than this. So for example, you could have a force that's coming out this direction, or this direction, this direction, and this direction. And perhaps later in this course or in another course, you would see how you could use trigonometry to figure out the angles. But we're going to keep it simple, or we've kept it simple. So we're concerned with only these four forces. Okay. Now this force going down here typically is gravity, right? You have a gravitational force that pushes the body down. Okay. Now you also have a force sometimes that acts going up. So for those of you who worked out that worksheet that we did the other day in class, the force going up is typically air resistance. You can sometimes have like a table. So if this was, for example, this diagram, if it was resting on a table, then you'd have gravity that would push it down, but the table has a force that keeps it up, right? These are some of the typical examples that we've seen in class, okay? But you can also have horizontal forces, okay? So you're going to have a force that pushes it to the right. So you may have, maybe I'm literally just pushing to the right. Okay, that's an H. Pushing to the right. And while you push to the right, you may also have a force over here. And usually this force is friction, right? So as you try to push something to the right, you experience some friction. Now, what are you going to see on the exam? Well, you will see questions that will ask you what's going on. So a typical example is, let's say we have 60 newtons of force pushing up. You also have 60 newtons of force pushing down. And you have 8 newtons pushing here and 3 newtons of friction. Okay, so how much force do we have? So if we think about this is not too complicated. You have 8 newtons pushing you to the right, and you're being pushed back by 3. So how much force do we have going to the right? Well, if we're getting pushed back 3, we have a total of just 5 newtons of force. Okay, and that would be all that's going on. Notice also I completely neglected the 60 and the 60 because these balance out. These guys are balanced out, so they're not a factor. Now we could have another situation, okay, where you have, let's say there's no horizontal force, right? Where you're getting pushed up 60 newtons, and then you have an additional 30 newtons of force. So how much force do you have total? Let's say that we're in a vacuum and no gravity exists, right? So if we're pushing up 60 and then pushing up 30, we've pushed up a total of 90. And this is to an extent as far as it's really going to go on the exam. So as long as you're okay with understanding the direction, and if they're going in the same direction you add, and if they're going in different directions you subtract, you'll be fine. Okay? Now some vocabulary that shows up is terminal velocity. Okay? You actually saw this, for those of you who did the worksheet last time in class, you see this term over and over again. And terminal velocity, according to Google, is the constant speed that a free-falling object eventually reaches when the resistance of the medium through which it is falling prevents further acceleration. It's almost like where the terminal typically means like terminate. It's when acceleration terminates. Okay? So I think a better way of illustrating this is in this diagram here. Okay? So what happens is when you drop something, it initially starts to fall, right? Then the object begins to accelerate, but you also have some air resistance, right? And then eventually the air resistance and the object reach a certain point that we call terminal velocity, where this value here and this value here are more or less the same. Okay? So as long as you remember these key ideas, free body diagrams are not going to be an issue. One other comment that I should make is that unless it says otherwise, there's always going to be a force of gravity that is acting on an object. Okay? Now, again, if it's on a table, you have another force, namely the table, that is responding, right? But no matter what, I just want to emphasize this, that unless it specifies that you're in a vacuum or in a situation where it's not the case, you always have some gravity that is attacking the object. So keep that in mind. Alright guys, hopefully this helps you out. After you've watched this video, you are ready for your test. So good luck, and I hope this helped you out some. I'll see you guys when I see you guys.